Hi, Assalamualaikum. My name is Farah Izzati Binti Rosli. My number matrix is B0822103130. I'm from BEEI section 1 stroke 2. Transfer function is a mathematically representation that relates the input and output of a system. It describes the relationship between the Laplace transform of the output variable and the Laplace transform of the input variable. Assuming all initial conditions are 0. A transfer function consists of gain, zeros, poles, simple zeros, quadratic zeros, and lastly quadratic poles. So first of all, I'm gonna explain about gain. When the frequency component of the transfer function such as S is replaced with 0 in the system transfer function, the result is referred to as a gain. Secondly, zeros. The numerator of the equation is where the zeros are positioned. We use this equation to get the zeros. The zeros we use 0 equal to JW. Thirdly, poles. The denominator is where the equation's poles are located. We use this equation to get poles. The poles we use 1 per JW. Fourthly, simple zeros. The term in the numerator need to equal 0 in order to reach the zeros, which are the equation's roots. These for simple zeros. In order to get the zeros, we use this equation. Next, simple poles. When the term in denominator is equal to 0, the poles and the equation's roots are the same. This is for the simple zero. This is simple poles. In order to get the zeros, we use this equation. But last but not least, quadratic zeros. The numerator of the equation contain quadratic zeros which must have power of at least 2. We use this equation to get quadratic zeros. For simple zeros, we use quadratic zeros equal to s plus 10 power of 2. Lastly, quadratic poles. The denominator of the equation contains the quadratic poles which have at least a power of 2. We use this equation to get quadratic poles. For simple pole, we use quadratic poles equal to s plus 2 power of 2.
Hello, Assalamualaikum. My name is Hasbullah bin Farid. Today I'm going to show you about transfer function to dot plot. Here is the equation, which is 5 in column j omega plus 2 over in column j omega, and in another column is j omega plus 10. And after derivation, and we can conclude that the final equation is in column 1 plus j omega over 2 over in column j omega, and in another column is j omega plus 10. From there, we can conclude there is 2 simple zero and 1 pole at the origin. And the first simple zero is 1 plus j omega over 2, and the z is 2. And another one is 1 over in column 1 plus j omega over 10 and the value is 10, and another one is 1 over j omega, which is pulled at the origin. And as for the first function is 1 plus j omega over 2, and the gain value is 2. So from 0 until 2, the value is constant. Then from there, we can put the value for the decade of 2 is 20. Then the decade for 20 is 200. And from there, after we plot, we can make one straight line to determine the function plot. And as for the first function is 1 plus j omega over 2, and the gain value is 2. So from 0 until 2, the value is constant. Then from there, we can put the value for the decade of 2 is 20. Then the decade for 20 is 200. And from there, after we plot, we can make one straight line to determine the function plot. And as for the next function is 1 over j omega. It has no gain, so the line will be decreasing. So we start from 0.01, and the decade for 0.001 is 0.1, and the decade for 0.1 is 1, then decade for 1 is 10, and the decade for 10 is 100. And from there we can make a straight line to show us the plotting. And as for the next equation is 1 over 1 plus j omega over 10, which is the gain is 10, but because of it being under the equation, so the line that will be produced is decreasing. So from 0 to 10 is constant. Then from 10, the value for it is the decade for 10 is 100, which is being plotted at negative 20. Then the decade for 100 is 1000, which is being plotted at negative 40. Then after that, we can connect the plot together to show us where is the plot. The next is magnitude resultant line plotting, which is I will show you the calculation to get the value to plot this line. And for the next one is the value that have been obtained from after we plot the board plot. So there are 6 points, which is consists of 0, 0.1, 0.2, 0.10, 0.20, and 0.100. As 0.1, we can see from 0.0, it is only 1 point have been plotted at 0.0, which is for the answer is 0 plus 0 and plus 40. And at 0.1, we can see there is no point have been plotted at that line, even though there is 1 point at 0, but the value remains 0 because it has no gain increasing or decreasing. So for 0.2, we can see there is 1 point, which is negative 6. Then for 0.10, we can see there is 2 points, which is 14 and negative 20, which is resulting the resultant line point to be plotted at negative 6. And for 0.20, there is 3 points, which is resulting 20 plus negative 6 plus negative 26, which brings down the value of negative 12, and negative 12 is the value that we need to plot to complete our resultant line. And lastly, the point 100, which is consists of 3 points, which is 34 plus negative 20 plus negative 40 brings us down to negative 26, and that being the last point for us to complete the resultant line. Then after we have complete our plotting, then we join all the plot together, and that creates one fine design line. So next I'm going to show you how to plot phase plotting. So from the equation 1 plus j omega over 2, we can first we plot at 0.2, then a decade for that is 20. From there we have to plot, and we can stretch our straight line, and there is resulting our phase plotting for 1 plus j omega over 2. Next is for the equation 1 over j omega. Since there is no gain in this equation, so we should put it on a straight line at negative 90. And next is for the function 1 over 1 plus j omega over 10, which is simple 0. So first we plot at 1, and the decade for 1 is 10, but in this case we plot at the decade for 10, which is 100, and then from there we can pull a straight line out of this plot. I'm going to show you how to plot the resultant line. The point is being obtained after certain calculation have been done. So after this, I'm going to show you the calculation for the resultant line. This is the calculation for to plot the phase plotting resultant line. So from the graph, we have obtained 4 points, which is 0.2, 20, 1, and 100. So for point 0.2, it is plotted at 1990, and at point 1, it is plotted at negative 63, and at point 20, it is plotted at negative 54, and lastly at point 100, it is plotted at negative 90. Thank you.
Hello, my name is Firdaus bin Iskandar, and my matrix number is B0822100424. Today, for my part, I would like to explain on how to get the transfer function from a complete dot plot. From the question, the resultant line start at 20 dB, which is the gain. To determine the gain, we can use the equation 20 log base 10 k equal to 20 dB, because the equation gives us the start at 20 dB. To find the k, we can use the equation 20 equal to 10 to the power of 20 over 20. Then we can get the k equal to 10. This is the progress that I redraw. This is the starting resultant line. Next to determine the simple zero. The line then increase at 20 dB, which is that we call simple zero. This the line that increase 20 dB. For the equation, we can use the equation is 1 plus j omega over z. The z is at the z is equal to 10 rads because it is increased at the 10 rads per second. So the simple zero equation is 1 plus j omega over 10. Next, we need to determine the first simple pole. The line maintained at 40 dB. Here, the line is maintained at 40 dB. Then the equation to get the simple pole is 1 over 1 plus j omega over z. The z is 100 rads per second because from the equation it's maintained at the 100 rads. So the first simple pole equation is 1 over 1 plus j omega over 100. Next we determine the second simple pole. The line from the plot, the line will be decreased 20 dB. So for the equation 1 over 1 plus j omega over z. Z is 100 rads per second because from 1000 rads per second. how do we got the Z from the dot plot. So the second simple pole equation is 1 over 1 plus j omega over 1000. Next, to get the transfer function from the standard form, in the standard form, sorry. First, we need to multiply all the equation that we got here. Then, from this equation, we need to simplify to get into the standard form. If you can understand this from this slide, we show the calculation next. Here's the calculation that I do. Thank you. That's all from me.
Hello, Assalamualaikum. My name is Mohd Iqmal Afiq bin Yusdi. I'm gonna present about the discussion from this assignment. In this assignment, the transfer function h omega of a circuit is the frequency dependent ratio of a phasor output y omega and element voltage or current to a phasor input x omega source voltage or current. We having trouble to find the transfer function at first. After we get the transfer function, we can apply the dot plot using the transfer function. To obtain the general state equation, magnitude dot plot, phase dot plot, and identify the zeros and poles for the given transfer function. The general state equation for the transfer function can be obtained by factoring the transfer function and simplify the expression. Finally, we are able to complete the dot plot using the semi-log graph to plot the magnitude and phase response on logarithmic scales. Finally, the conclusion that we can conclude from this advanced electrical circuit assignment, the magnitude dot plot shows the logarithmic magnitude response of the transfer function over a range of frequencies. To plot the magnitude dot plot, we need to calculate the magnitude in decibels as a function of frequency in radians. Using the general state equation from the transfer function, we can identify the locations of the zeros and poles. Next, we are able to apply the knowledge about how to dot plot using semi-log graphs. The semi-log graphs can be used to plot the magnitude and phase response on logarithmic scales. The x-axis represents the frequency in logarithmic scale and the y-axis represents the magnitude in decibels for the magnitude dot plot and the phase angle in degrees for the phase dot plot. Finally, to find dot plot, we must obtain transfer function corresponding to it. That's all from me. Thank you.